myths that lead to abuse of big data. My favorite myth is when people say that data should speak for themselves. It is tempting to think that data should speak for themselves. There was a well-known case written a few months, maybe a year ago, in the Times Magazine about, I think it was Target, that was able to predict who was pregnant based on a bunch of purchases. And that was sort of framed as an example of data that are let to speak for themselves. You know, that if you just get enough big data, like with enough big data, you know, a story will emerge. That is essentially never how these kinds of analyses really happen. There is almost always a hypothesis. There is almost always someone who is very smart and curious, who has first of all collected the right data and put them together in the right way to allow something like that to emerge. People are also tempted, this is the second myth, that more data means less need for models. And you know, I hinted at that earlier when I talked about the way that we and others test site improvements on our own website improvements. That you know, you might have to do less forecasting, less modeling using proxies, if you have enough big data to test things ex post. Occasionally that's actually true, but usually it's not. Having more data doesn't lessen how critical it is to have a hypothesis for how the world really works. You know, there's the old joke of the person who heard that most accidents, you know, occur, you know, within a quarter mile of home, and so he moved. Now, more data on accidents, beautifully visualized data on accidents, wouldn't have helped him one bit understand what was really going on. That's an example where if you're starting with the wrong model or wrong point of view, all the data in the world isn't going to help you get close to the truth. The third abuse is the belief that with more data, errors average each other out. Now, that is true only in a very particular case. If you're doing a random sample, if you do a random survey, yes, the more people you sample, the smaller your margin of error gets, and the closer your sample gets to approach your population. In most cases, though, errors in data do not come from random samples that were too small and can get larger. Most errors come from someone screwing something up, something inadvertently getting cut, something that didn't match or merge correctly. These are the errors that really make a difference and are incredibly annoying. And with big data, they are sometimes even harder to see. It's much easier to see those kinds of errors, these errors that really matter, when you have a small data set that you can sort of look at very easily, or sort it, or actually see every observation. You need more sophisticated diagnostics to even catch these errors with bigger data in the first place, and it's especially dangerous when people assume that more data probably means cleaner data. It doesn't, and it makes the dirty data harder to find. So the best way to use big